Hi girls. Today we're going to be talking about the ups and downs of slopes. I'm sure you've seen this sign when you've gone to the Grand Mall, right? When you get off on Lambert, you see a sign like this that says has a picture of a truck going down a hill and it says 8% on it. Do you know what that means by chance or no? Janelle, do you know what that means?
No.
No. What it means is that there's an 8% downhill grade. That means for every 100 feet that the truck travels horizontally, it's going to go down 8 feet. Okay, next slide. Okay, this red X at Magic Mountain, there's a portion of, after you go up the hill, once you reach the top, then you descend at an 89-degree angle, or an 89-degree angle of depression, which is equivalent of moving 1 foot horizontally for every 60.1 feet it moves vertically. Next slide. Okay, so what we're going to do is introduce some key terms here. So the first term that we have here is rise, which is vertical change. Like from here to here is the rise. Okay, so like, in order to calculate the rise, what you would do is you do the high point minus the low point. And the next term we have here is the run, which is the horizontal change. And the way that we calculate that is we do the point furthest to the right minus the point furthest to the left. Okay, so what is a slope? Okay, here the slope is the rise or vertical change divided by the run or the horizontal change. So here's a simple equation. Rise is equal to rise over run. Or another way of saying that is that slope is the vertical change divided by the horizontal change. Okay, let me give you talk about some types of slopes. The first type of slope that we have is the positive slope. With the positive slope, we know that the slope is going to be going upwards. Going from left to right, it's going to be going from down to up, so it's going to be on a positive slope. So like imagine if you're walking up a hill, that's going to be a positive slope. Okay, the next slope that we have is a negative slope. Of course, if we have positive, we can't have it. If we have a positive slope, we can't be without a negative slope, right? So the way that we see this is that as the line moves from left to right, the line is actually is decreasing. You kind of see that. Imagine walking down the hill. Okay, next slide. Okay, the third slope that we have is called the zero slope. So the zero slope, does not go up or it does not go down. It's just a horizontal line. So just imagine walking across a flat surface. Okay, next slide. Okay, and the fourth slope we have is an undefined slope. Unlike the positive slope, which goes up or a negative slope that goes down, or a zero slope that's horizontal, the undefined slope is a vertical line that goes up and down. Okay, let's do a little bit of review. So the first thing that I want to do is see if you girls remember how to plot points. Okay, so what if I wanted you to plot 2, 3? Do you remember how to do that? Elizabeth, you want to show me how you would do this? So what would you do?
2, 3 would be, so 2 is on the x-axis, so you find 2 on here, so it would be 0, 1, 2. Then you go up 3, so 1, 2, 3.
Okay, that's where 2, 3 would be. Okay, where would negative 2, 1 be? Go ahead. So what does the negative 2 tell you to do?
Go below the x-axis.
To the left of the. Because remember, here's the origin. What we do is we're going to move either left or right first. If it's positive, we move to the right. If it's negative, we move to the left, right? So if we have an x origin of -2, which way are we going to go?
Left.
Okay, so where's that going to be at? So here's the origin.
0, 1, -1, -2.
Okay, and then how are you going to plot -2, 1?
When you have a positive for the y-axis, you go up.
So what you're going to do is you're going to go from that point, -2, and then you're going to go up 1. That's good. Okay.
Go sit down.
Not yet. Yeah, one more problem. How about this one? 1.5 comma -1, -1.
You go right.
So right, how far are you going to go to the right?
You go 1, then half of 1.
Yeah, so it's going to be right between 1 and 2. That's right. And then what?
Then, since it's negative, you would go down to the first line.
Okay, so your point would be there. Okay, so go ahead and push left side. So there you have your points. You have 2, 3, -2, 1, and 1/2, -1. Okay? Next slide. Okay, so what we have next is we have the slope formula. Okay, what we do is we represent the slope by the letter m. It's a universal term. I don't know why it is, but it's been used for many years, and it's standard. Okay, so let's say we have 2 points. The first point, which I'm going to label x1, y1, and the second point x2, y2. And then what I'm going to do is I'm going to find out, okay, what is the slope between the 2 lines? And then I'm going to use these 2 points, and I'm going to plug them into this slope formula to determine what the slope between the 2 lines is. And the slope between any 2 lines is y2 minus y1 divided by the quantity of x2 minus x1. Okay, next slide. Okay, let's do a couple examples here. So we have 2 points. We have 1, 3 and 5, 11. So what I want to do is want to figure out what's the slope between those 2 lines. Okay, so all I'm going to do is I'm going to label this one this point 1, this point 2. Okay, and then so this is going to be x1 y1, and this is going to be x2 y2, and I'm going to plug these points into my slope equation. And then I'm going to substitute in. So we know that y2 is 11, y1 is 3, x2 is 5, and x1 is 1. And as we have the quantity 11 minus 3 divided by the quantity 5 minus 1. And then we simplify that, we get 8 divided by 4, and then 8 divided by 4 is going to be 2. So the slope between those 2 lines is going to be 2. Okay, another example that we have here is this points -4, 2 and 3, 2. Okay, so I'm going to do the same thing. I'm going to label this point 1 and this point 2, and then I'm going to plug these numbers into the equation and simplify and solve for m. So x1 y1, x2 y2. So you got y2 minus y1, so 2 minus 2, divided by x2 minus x1, 3 minus -4. So, 2 minus 2 is 0, 3 minus -4 is 7, and 0 divided by 7 is 0. And remember that 0 divided by a number is 0, and anything divided by 0 is... Undefined. Yeah, it's undefined. It doesn't exist. Okay. So, what I want you girls to do is I want you to see if you can calculate these, find the slope between these 2 given points.
So you get y2 minus y1, so it's 2 minus 0.
Yeah, 2 minus 0.
Then you get divided by x2 minus x1, so you get 2 over 4, and that equals 1/2.
1/2, that's right. Elizabeth, you want to work on this one? You want to try this one? I'll help you along. I'll help you out. So what we do is we do y2 minus y1. So, this is our first point. This is our second point. Okay, so we got y2, which is going to be -1 minus 5. What's -1 minus 5?
-1 minus 5 equals -6.
So it's -6 over x2 minus x1, which is going to be 2 minus -1. What's 2 minus -1? 3. And then you got -6 over 3 is what? Okay, positive divided by, or negative divided by positive is,
Negative.
and then 6 divided by 3 is
6 divided by 3 is 2.
2. So your slope between those 2 points is going to be -2. Okay, well, let's try this other one. Okay, so we got first point and second point. So we got y2 minus y1. So what is that going to be?
0.
0 over 7 minus 3, which is what?
4.
4. And then 0 over 4 is going to be
0.
0. That's right. Okay, and how about this fourth one? Okay, let's try this one. So we got y2 minus y1, which is going to be what? So we got 5 minus -3 is
8.
8 over -4 minus -4,
0.
0. And what's 8 divided by 0?
8 divided by 0 is 0.
No,
Oh, wait. Oh,
other way around.
nothing.
No, you can't do it. Yeah, which is undefined. Okay, so do you remember what the definition of slope is again?
Is it rise over run?
Yeah, it's rise over run.
Vertical
change
over horizontal change?
That's right. Okay, so what we're going to do is we're going to do a couple of activities in order to calculate, the slope amongst different objects. Okay. For example, what I'm going to do here is, let's say, I wanted to figure out what the slope is across the diagonal of this screen. Okay. So across here, what's that slope going to be? Assuming this is kind of the bottom part is x-axis, the vertical part is the y-axis. Okay. So what I'm going to do is I'm going to calculate the slope of the diagonal across that screen. Okay. So what I'm going to do is I'm going to take out my trusty measuring device. Okay, so from corner to corner, so the horizontal change is going to be 28. Okay? The vertical change is going to be, just to make it easier, it says 15.5, okay? Just so that we don't have any fractions, let's say the vertical change is 16, okay? So what's the slope across the diagonal? What would that be? So, the vertical change is 16, the horizontal change is 28.
28 over 16? Oh, wait, 16.
No, it's rise over run. So what would that be? So it's 16 over 28. It's a you can leave it in fraction form. So what's 16 over 28? Remember, they're both multiples of 4, right?
Yeah.
So what times 4 is 16?
4 or 7.
Yeah. So the answer. So the slope across the diagonal is going to be 4 over 7. That's right. Okay. Let me do another example. Let's say I wanted to figure out, doing the same thing, but using the slope across the diagonal of the window. Okay. So I'm going to take out the measuring device again. I should know this. Elizabeth, you want to help me with this?
Sure.
Just line it up on just the edge right there. Okay, so we have the horizontal change is 57. Okay, and we have a vertical change of 47. Okay, so horizontal or vertical change of 47 inches, horizontal change of 57 inches. So what would the slope of that be? Because remember, 47 is prime, so you're not going to be able to reduce it. So what's the slope of that? What would the slope of that be? Remember?
If it's in decimal form, it's...
No, just leave it in fraction form.
Oh.
So remember, it's just...
47 over 57?
Yeah, it's just 47 over 57, so that's the slope.
Oh, okay.
Okay?
Yeah.
Okay, so what I want you to do is I want you to see if you can calculate. Let's say if I have a a little plank, okay, and I ask you to figure out, okay, what's the slope going across the diagonal there? Okay, so, do you know how you would do it? You do it the same way that I did, the slope here. So what you do is you figure out what the horizontal change will be, the distance from the corner here to the edge right here, and then the vertical change, which would be just the distance from the floor to the edge right there. Okay, so you want to do that for me? You could work with there, Elizabeth.
So it's right here.
And actually, remember when you're calculating the slope, you don't measure out across the diagonal. You measure horizontal and vertical distances. So what did you get for the vertical distance?
32.
Okay, and what's the height of that? Okay, so remember it's going to be vertical change over horizontal change. So it's going to be 24 divided by 32.
2 is 1/4. Wait.
20.
3/4.
Yeah, so your slope there is going to be 3/4. Okay, that's good. Okay, so that's very good. You can go ahead and sit down again. Okay, so what's the definition of slope again?
Rise over run, which is vertical change over horizontal change.
That's good. So why do you think it's important that, remember that sign that I posted up first of the truck and the angle? Why do you think it's important that truck drivers know the downhill grade?
So they know to reduce their speed.
That's right. Because what happens if they're going downhill and they keep the same speed?
Gonna crash.
There's going to be accidents, right? So how do civil engineers calculate, the downhill grade? The people that actually make the roads and stuff, how do they calculate the downhill grade?
Using the slope.
Yeah, what they're going to do is just calculate slope. They figure out the horizontal change, or figure out the vertical change, and just going to calculate slope and then convert that to a percent. Okay, so any other questions?
You got a question?
Oh no, I get it. It's good.
Okay, all right. Thank you very much.